Hi there, we're going to get started soon, but not immediately, so continue talking.
It's okay. Yeah. You're a bad person because you're doing DNS instead of doing right. Yeah. It is actually really frustrating. Yeah. It's more frequent that there are some groups that I have to go to in the same slot that I don't want to be in. Yeah. But I'll give you a presentation. Yeah.
Okay. Greetings. We're starting a few minutes late. I apologize. Hello? Hello? Can you hear me? Can you hear me in the back? Okay, thank you. Or you can speak less loudly. So, hi. I'm Paul Hoffman. I am chairing. So someone just told me, I just revised the slides. Someone told me that many people were, hey, folks, we're starting. And when we say we, I mean me. I was just told that there were multiple hallway conversations today about the BOF, and many people didn't understand that this was not a working group forming BOF. So let me emphasize, and that's not a change, that's always been the case. This BOF, and by the way, there's the, what's in the middle of that? I'm not seeing that here. Is that, thank you. Warren, handle hardware, thank you. So the origin of this BOF, Oh, and yes, thank you. And by the way, I am sucking today as a BOF chair. I'm late. I did these slides moments ago, and I forgot to start the blue sheets. Warren, would you do me a favor? So the origin of this BOF was that there were some issues that came up on the DOE in the DOE discussion that weren't DOE specific, that they were sort of side thoughts. And people said, oh, we should deal with that. We didn't want to deal with it in DOE per se. I talked to the area directors and they said, sure, let's have a BOF, but let's not assume that it's working group forming. There is some interest in some of these things, but as you'll see when we get to the topic list, they're quite diverse. Writing a charter for a BOF with a whole bunch of diverse ideas is easy. Writing a charter for a working group with a whole bunch of diverse ideas ends up in tears. So this, a working group or working groups might come out of later work, but there's going to be no charter discussion today, and there's going to be no charter discussion at the end. In fact, we sort of have a fullish agenda, although I could be wrong, and the speakers might be fast, and so I'll be surprised. So please don't think of this as the first meeting of DRIU. I'm sorry, DRIU. I can't even, I purposely chose it so it wouldn't be able to be pronounced, and I've just proven that that's true. Yes, and Murray says it's French, which is good because I don't actually speak French. So this is a BOF with a melange of ideas. And now I'm going to prove that, oh wait, which magic do I need to do to, I did. I'm sorry? Mouse at the bottom right. Thank you. And the little square dude. I am now fuller. Okay. So here's the agenda, and I might actually take up a reasonable amount of the 15 minutes because we've got a couple more slides with, for those of you who heard about the BOF but didn't actually read it on the BOF, the IETF's BOF wiki, we'll do that. We've got a bunch of presentations. Do you need to hop in and meet a co? Okay. And we do have a couple of, known folks away. Okay, you can futz with it. That's fine. Don't worry. No, that's fine. I'm as organized as you are, so. Yeah, I'm sorry, I just insulted the Mitico people. Sorry. And actually, I have no good excuse for being this disorganized. I was going to do this all at lunch. I was having a nice lunch, and I totally spaced it out. So we've got a bunch of presentations from people who said on the list that they wanted to do things. We've got slides for most of them. Sarah has said if we don't get to her, that's fine, but she has no slides. But the levels of security and privacy is something that's very interesting. We will go through this if there's time at the end. Great. I'm now going to hold this guy again. So on the reason that we got this BOF approved, so for those of you, I know that there's some newcomers in the room, when you propose a BOF, you have to actually sort of say what you're going to talk about, and is it working group forming and such like that. Since this wasn't working group forming, the area directors and IAB, whoever approved it, actually let me throw up just like a bunch of bullet points. And so these are 3 of the bullet points. The first one that made me think, oh, we should do this is right now, you get your address of your DNS resolver from DHCP as an IP address with no indication of is this actually DNS over port 53 or port 853 or DOE or some future thing. So how to identify it? Now, what we will have actually is some presentations on, do you even want to do that? Is this a good idea or not? And so that's one of the ways we'll start. For people who care about their DNS resolver running over TLS and actually want it authenticated, if you've gotten an IP address, well, then you're going to hope that that IP address is in the certificate. Does that work now? We don't have any slides on that today. No one actually wanted to step up to that. There are lots of ideas in that area. If the PKIX working group was still around, and believe me, I'm not asking for the PKIX working group to still be around. That was decades of agony. That would come up. We also, now that DOE is getting sort of close-ish, Martin, did you have a clarifying question?
Yeah, Martin Thompson, are you asserting that you can't put an IP address in a certificate?
No, I am asserting that many people think that it's hard to get them, and therefore that's not what you want. And it's true that there are many CAs who will not give you one, or if they will give you one, that the way that they would validate that your IP address was right wouldn't actually work for a DNS over TLS server. So, you know, that could be an issue, but again, not an issue for today, but if this is something that interests you, something for the mailing list, because we do actually care for DNS over TLS, and well, I'll take Doe off for a moment. How do you authenticate? So I've just mentioned 2 different transports for DNS, port 53, port 853 with TLS. The second one seems to have some security properties. Now, which security properties it has for you as an end user is up to you, although in the IETF we tend to tell people what they think the security properties of something should be. So do we want to tell the users what they are? Do we want to rank them? You know, how does this happen? Again, no slides on this today, although Sarah might deal with this a bit if we get to her. But this can be tricky. And I thought there would be juice in this. That didn't come up on the mailing list so much. Flipping it around, how can a resolver that is sitting out there say, I've got these capabilities? That gets even trickier. Again, not a discussion for today, but many people had expressed interest specifically in this on the DOE mailing list before, probably before draft 4 or so. This fell off, but it is something that might be nice to do without the client just probing. And I believe, Ben, the Android client goes out and just sort of probes, right? Yeah. So Android, a new client that's shipping or soon to be shipping in typical things, says, I've got an address. Let's look on 853 because 853 is good. Things like that. Yes? Oh, you're not going to tell us about Android, I suspect.
I am, Eric
Okay.
Klein. If by probing you mean just probing for specific services, it can only probe for TLS.
Yes.
It cannot
Right.
probe for DOE.
Right. Yes. So, and we also, I mean, God knows that because DOE allows you to specify the endpoint of a DOE server with a URL, someone could put a :853 in the middle there and make everyone whine. So these kinds of things, though, might want to be discussed at some point. And then the last bullet I had put up there, I thought this was actually really interesting. No one showed any interest at all, is that we actually have a DNS URI. Oh, I saw, Ted, yay, yes. Ted's out there cheering with me. Hey, we have a URI scheme. If someone says, you know, what's your DOE server, you know, and it needs to be a URL, we've got a DNS URI for the other things, right? Is this useful? Probably not. So that's the topics for discussion for the mailing list. And again, for those of you who are in the wrong room but now think it's interesting, that's how you can get on the mailing list. But for the session today, this is the agenda. And I want to emphasize that these are maybe related, maybe unrelated talks. This wasn't meant to be a grand plan. These were the people who stepped up to say that they would do this. So any questions on the agenda? Cool. Okay. Tom, why don't you start off? Oh, why don't I make it so you can start off? Oh, boy. I hate it when BOF chairs do this. Which one are you giving? I'm sorry. Thank you. But I like it when people who are helping me do that. And we do this, and we do that.
Oh, you're making wrong slide.
That's the wrong slide.
I'm over here.
Well, he said do it from the top, so now we undo that. Yes. I was getting people excited for your talk, Mark.
Thank you.
The threats.
Yeah.
Threats. Thank
Yep.
you. Except that I'm in full screen. Very good. And we go down here. And we go up here. No, we go up there, and we hand this guy to you. Or do you want me to do it since you're going off your pad?
No, this is fine.
Okay, cool. Thank you.
All right. So when Willem and I talked about doing a DHCP option for secure DNS parameters, Ted Lemon challenged us to, think about the threats that we would be solving as well as the threats that we would be creating. And so we decided to do this analysis first. Well, probably at the same time as we were doing the document. I used there's a modeling of threats called a stride method, and that's what I used here. It doesn't coincide exactly with the RFC that Sarah has produced that talks about threats. That might be something we would synchronize in the future. But we identified these threats, disclosing information on the wire, basically, of packets that are going by, and being able to tie them to a client. On the resolver itself, being able to log or analyze or use the private data that the queries contain when they're sent and the responses come back. Maybe a rogue DHCP server would send you a DNS server that isn't part of the infrastructure, and you would send your queries there. The queries or the responses could be tampered with, either on the way out or on the way in. There's not a lot you can do to the query, but I was thinking there's one thing you could do is maybe if you change the class when it went out, and then when it came back with no response, then maybe the software wouldn't check that the class didn't match or something, and maybe you would end up with denial of service there. But the responses could be modified. There's the case where an X domain is returned when there's actual real results, and or actual errors put in for addresses and things, such that you would go to an address that either is a rogue server or something that doesn't exist, so it'd be a denial of service. As far as what mitigations are available for these threats, there's, if you think about it, before we add extra parameters to DHCP, what can we do today? There's nothing that we can really do about the information on the wire. There's nothing we can do about what the resolver does with our queries. You can attempt to do TLS like the Android guys just mentioned, but that introduces a delay. But there's nothing that we can do about what's happening on the resolver itself. As far as the resolver being not really being the one you think it is, because you don't have a name, we could do a pointer query and come up with a name, and then check that name for the certificate and things. But that also introduces additional delay. And it's kind of a bootstrap problem, because what server do you use to get the pointer query from if you don't trust it? In the case of the last three, DNSSEC can solve those, but typically that's not done at the client side. That's done at the resolver for you. So you would have to do it at the client in order to get that trust to know that the responses coming back really haven't been tampered with. Otherwise, you're trusting the resolver.
Ben Schwartz. What is repudiation?
It's basically a denial, like saying that something doesn't exist when it actually does. So it's like saying there is no you get NX domain back because we're saying that there's no answer to that query when there really is an answer.
Okay. I guess my broader question is really about denial of service here. How do you see DNSSEC solving a denial of service problem here?
When you get that NX domain back, you can know that if it's been validated, you know those records exist or they don't exist.
Right, but if you, so if DNSSEC validation fails, or if you don't get a response, then how does DNSSEC, what is DNSSEC's role here?
Yeah, in that case, it doesn't help you.
Paul Wouters, that was also my point. There's no protection from denial of service by DNSSEC.
Okay. Even NX domain.
I think they're thinking of denial of service differently than you are.
Okay.
Yeah.
Okay. So next, if we add the ADN, like an option, a DHCP option with a name, that helps us here, because now we know if we have the extra DHCP server options, we know that TLS is supported or DOE is supported or whatever. So we can go right to that on that port number and don't have the delay. We still don't know, if things will be, monitored on the resolver itself. But that's the kind of thing that you have to pass around by reputation, I think, is the way we solve that one. Question?
Clarification, Lorenzo Colletti. What do you mean by delay? Like what delay are you referring to?
I'm
precisely?
referring to the delay of trying to see if DNS over TLS is provided, and if not, then falling back to just normal DNS. So you introduce an additional delay there by probing for TLS.
But if you did, so if you did those two in parallel, then there would be no delay. So in that sense, I see.
Yeah.
Okay.
As far as spoofing of the resolver, by having a certificate that you can check in DNS, that you can get it, an actual, you verify the certificate. You could use DANE to get TLSA records and verify it, or you could use an out-of-band mechanism like the SPKI PIN to verify the certificate. You now know that you're talking to a resolver that's probably, if it has a TLSA record, it's somewhat respectable. It may still be doing bad things, but at least you can clearly identify it. And I think that's a big step forward, because now it becomes part of the reputation system that we can decide these guys really are these guys and they're doing something bad, as opposed to someone who's rogue. I think, one of the ways that we can solve the problems that can't be solved in the protocol is a reputation service. And today, HTTPS has this with the OCSP, where you can get information about the status of a certificate. We could do something similar but different. The operating system vendors or the DH client software vendors could participate. They could have blacklists and whitelists, and that could get updated dynamically or statically or in updates. The server that Sarah runs of DNSprivacy.org already has a list of servers that have that are reputable. That could be a starting point. But the foundation of having authenticated servers gives us the ability to then build this reputation and know that we're talking about the right servers that are authenticated. So to summarize, DNSSEC does help us know that the information we're getting back from DNS is authentic, whether or not the DHCP server sent us to a good DNS resolver or not. If we can verify that the answers are correct, then we don't care. So that's an important part of the integrity of the answers, but doesn't get us everything that we need. And being able to authenticate the server itself through, the certificates of over DO or DOT helps with the integrity of that server. Let's see.
Sarah Dickinson, I just wanted to just clarify slightly the list of servers we've got on dnsprivacy.org. We're quite careful to say that we can't vouch for them apart from the servers that the GetDNS Stubby developers run. We are just saying what we've been told, and that's one of the issues we're trying to solve, is that we can't verify what they say about their operations.
Sure,
So
but you do provide pins and things that are for use in verifying the certificates that are there.
So we have an out-of-band mechanism for publishing those, but
Yes.
again, that's based just on
Right.
our trust in them. We don't have a separate channel
Right,
to
right.
verify that.
And
Yeah.
I'm not saying that that's the reputation service that we have. I say it's a basis for a beginning one.
Right, yeah.
Yeah. So one of the problems that we have today is it's hard to deploy DHC. It's hard to get DNSSEC deployed everywhere because of all the middle boxes that are there that are UDP, and you don't know they're there, and you don't know how they're interfering with the responses. And so if we could use TLS, DNS over TLS or DO to the resolver, we'd have the ability to get DNSSEC responses back probably much easier. That's what they found in Stubby, and I think that that's something we should consider deciding whether UDP is a good transport to use for DNS in the future between the client and the resolver.
Questions for Tom?
Tom, Ted Lemon. So when I started hassling you about the security model for this stuff, I was actually not really talking about the analysis that you just gave us. What I was talking about is suppose that you have a relationship with a DO provider or a DNS over TLS provider, and you have some basis for trusting them. You have some kind of legal agreement with them. They have some kind of fiduciary responsibility to maintain a certain set of agreed upon standards as to how they deal with your query data stream, and so forth. If you were, there are a variety of different ways that you could get the information about that resolver into your laptop or whatever it is that you're using to do your name resolution. And in order to do a security analysis, in order to do a threat analysis of this sort of space, you need to start at that level. You need to start at how does that information get into the resolver? What are the variety of different ways that information could get into the resolver? What are the attack surfaces that are present given each of those different ways that the resolver could be configured? And then you can start talking about the next layer down. But right now you're talking about the next layer down, and that's a concern. So I think in order to do this threat analysis, you really need to get all the way back up to 20,000 feet and look at the various different ways you can do this, and not just talk about the low level stuff.
Okay.
Eric Klein. On the previous slide, I don't want to start a whole discussion, but on a good day I can barely spell OCSP, and I don't know much about it. Therefore, why would the reputation service need to be different? Is there like a 2-line summary of? Why the existing stuff wouldn't work?
So the certificate could be fine on the DNS over TLS server, and there wouldn't be any, it wouldn't be revoked, it wouldn't, or anything. It could, and it'd show up in the OCSP status as fine, but it could be that they're logging your information.
Actually, Eric, Tom, are you talking about open resolvers in general?
Yes.
Okay, so I think that's what it was given a universe of open resolvers, what are their reputations?
Interesting. Okay. I hadn't understood.
Okay.
That. Thank you.
Oliver, and then you'll be last.
Thank you, Paul. Oliver, Amazon. So, first of all, yes, about the reputation of a resolver or what their policies is. We have no current mechanism either proposed or talked about that allows resolvers to state their policies. We have no enforcement of whether the stated policies are true. And addresses that are handed out on random networks have absolutely no meaning. Half of the hotels in the US will give out 8888 as one of the resolvers you are using if you're on that hotel network. And most of the time I can prove that those responses did not come from Google. So,
did they come from Cloudflare? No, sorry.
as I did this experiment before I turned up 111, which everyone should be using. Thank you for the.
But they weren't over TLS either.
Yeah. TLS is sometimes viable as a connection mechanism, and sometimes it's not. And so the fundamental question we have to ask also on this one is, what role does a network-provided resolver have to play in the game? Is it a bootstrapping mechanism to get you to a more trustworthy world? Is it something to be avoided at all times, or is it something to be used? And for a privacy or a statement about service levels of resolvers, in many cases, the edge devices want to offload work. They want to create a trust relationship with something that is properly maintained. And that is one of the reasons why many of these edge devices now want to talk over TLS or DOE to reputable or corporate supplied resolution engines.
Great. Okay, thanks. Thanks, Tom. Ted?
Tom.
That's okay, it'll work in two
Baseball
pieces.
days are over.
Yes. Into there.
It's kind of pathetic.
Which little tab did... Not a problem today. There we go, and there we go, and there we go. I think that should work, please.
Okay, so my name's Ted Lemon, and this talk is
By the
about.
way, I gave you 10 minutes. You want 15 or?
Let's. I
Okay.
don't think this should go too long. We'll
Okay.
see. So I'm here to talk to you about when to use DHCP. So a little history. DHCP. I've been around the DHCP world for a really long time. So my starting point was DHCP v4. The idea when we did DHCP v4, which I was personally not involved with, it was the DHCP v4 would configure everything in the stack: IP addresses, default routes, MTUs, configure your DNS server, your time server, basically all of the servers that were available, all of the services that were available on the network would be configured using DHCP v4, and it would even actually install your brain for you. So in order for that to even be remotely not stupid, there were some assumptions. First of all, the network had to be a safe place, and secondly, the host probably wasn't moving around much, if at all. If the host moved around, it probably needed a brain transplant, so it was okay that it was getting one. DHCP v6 happened a little later in history, but not that much later. There was a lot of resistance to even doing DHCP v6. So when we did DHCP v6, which I was involved with, we decided not to kitchen sink the config parameters. So there are config parameters for things we thought were actually necessary and nothing else. But we still kind of had the same idea in mind that the network was relatively safe. and hosts weren't moving around. Because I mean, this was happening. I remember the discussions we were having about this were at an IETF that occurred in DC in like 1999 or something, or 97 even.
97.
97, yeah. So
I remember that one.
Oh yeah, yeah. So that was a long time ago. Things have really changed a lot since 1997. There have been efforts to attempt to secure DHCP over time since then, many efforts. They have all failed. Keying is hard. Getting the threat model right is not obvious. And nobody really cared about doing it enough to actually do it. And the reason why that's the case is because every time we got to the place where the rubber hits the road, we realized that actually we were trying to do something stupid. That DHCP is actually never going to be safe. And so trying to make some kind of Band-Aid over that isn't going to make life better. So let me talk to you about why that's the case. So probably all of you already are familiar with these things, but I'm going to recite them anyway. DHCP happens when you change networks. That means that DHCP configuration information has to do with your network. It has to do with what network you're connected to. It doesn't make sense for it to talk about things other than that. Services that you want to use independent of what physical network you're attached to are not services that change every time you change networks, obviously. So for example, IMAP, SMTP, HTTP, SSH, NFS, these things, if you were to configure the name of, or the IP address of your SSH server using DHCP, that would be ridiculous. And also, DHCP doesn't give you the ability to choose services. So like your DHCP server couldn't give you a list of SSH servers and tell you which ones do what. That's just not in there. So even though DHCP has the ability to configure your LPR server, it actually really doesn't make sense to do that anymore. So we had a meeting many IETFs ago. I think I was an area director at the time, so that probably dates it somewhat, like probably around 2010 or thereabouts. And the meeting happened because Colin was working on some SIP stuff, and he wanted to be able to use DHCP to configure it. And I was dead set against having that happen for the reasons that I just explained. And so we had a big throwdown. And it was really kind of interesting. It was a big debate in the DHC working group with the two of us going back and forth, hammers and tongs. And the question was, when is it appropriate to use configure services using DHCP? So the argument in favor was that we needed to be able to configure SIP servers. We needed something to configure them with. DHCP is something. There wasn't an alternative to DHCP, so let's use DHCP. Arguments against. DHCP provides zero authentication, so you're configuring something that you're going to like make phone calls that might actually have security properties on, and you're not authenticating it in any way. Good luck. So also hosts roam. Even if you trust the network, the DHCP server on this network might not actually give you the right information that you need in order to actually make phone calls as you. So do we want hosts to use the SIP server on the local network? What's the trust model? Does SIP have a way to like, could we give you the SIP server information and you could validate it somehow? Is there a general principle here? And then what came back was, well, let's do the baby duck model. This is, we'll look at the, when you plug your SIP phone into the network for the first time, it'll do DHCP, it'll get the SIP server, and it'll just remember that forever. And if you move it to somewhere else, you just factory reset it. Otherwise, it never gets new information. So as long as it got good information the first time, everything's good. Of course, we now have a wonderful attack surface that we've created, A, and B, it's like really not using the DHCP flow. So DHCP is about repeated refreshes of information, and that's not doing repeated refreshes of information. So having a DHCP option to make that happen is the wrong thing. What you really want is a service that actually solves your problem, not try and shoehorn it into DHCP because DHCP does that. In order to use DHCP safely, there has to be a trust model for the service. Even if you have a trust model, DHCP doesn't have any way to verify it. And so using it to configure anything that isn't just like, you need this to use the local network. So if the local network tells you this, then either it will work or it won't. And like, what's your default router? Well, it sort of makes sense to configure that with DHCP, because if the network lies to you about that, you're just screwed anyway, right? So using DHCP to configure things other than that, my conclusion in this at the end of this conversation was that was a bad idea. This hadn't ever been clearly articulated before, so that's why I'm talking about this particular debate. And by the way, DNS is a service, and so if you're not using DNSSEC to validate in the stub, then getting your DNS resolver from DHCP is actually kind of risky. And the reason why I'm talking about this here is that that's one of the proposals on the table. And I think that we really need to think about whether that's actually the right model for configuring DNS resolvers if we actually care about DNS being private, secure, any of those things. If you're using DNSSEC and you don't care about privacy, it's probably fine to use DHCP to configure your server because you have backup. DNSSEC protects you. But if you actually care about the privacy of your packets, then maybe that's not the thing to use. So that's what I just wanted to set the sort of background about DHCP for this discussion.
And just, Alyssa, just hang on a second. Cullen, are you in the room?
I'm going to proxy for Cullen.
Okay, well, good, because there was, as Ted actually showed Cullen these slides first. This is like the third rev of the slides. Cullen's like, no, I mean, so the debate continues in my inbox. Please, Alyssa.
Alyssa Cooper. Well, okay, so maybe these are just some of the details you left out, but actually the SIP server configuration stuff happened way earlier, right? Like in 2002 or something.
Yep.
The more recent debate was about updating the document that specified the configuration option for your location server. So this is like, as you move around from network to network, you need your local location server to tell you so that you can put it in a SIP call to an emergency responder.
Mm-hmm.
And the document was published. So
I'm lost.
Yes. Not commenting on the argument itself, but
sure.
those are the details.
No, yeah, that's right. It was more of a discovery process than it was a victory for anybody.
Lorenzo Coliti, I think the answer to your question about when to use DHCP is not anymore. Now, everyone probably knew I was going to say this, but one thing that you left out is, in general, in DHCP, it's really hard to change anything.
Yeah.
And now for DNS, that may not be a problem, but generally speaking, when you're trying to configure the network information, networks do change. And so, next time you present these slides, just add a footnote. So you can't ever change anything.
So basically, Lorenzo, what you're saying is the DHCP sucks even worse than I said it did.
That's correct. One thing that I also maybe more usefully could say here, I think, is that in parts of the people working on IPv6 configuration, there's battles going on there, but there's a contingent that would like to use RAs for very, very minimal, can't get it wrong sort of local configuration information like addresses and routing, and PVDs for everything else. And PVD is it's an int area. Go read the draft. It's essentially JSON, and it's TLS authenticated and so on. So I think to some degree what we're saying here is that there are things that are specific to the network that you're on and you don't trust them, but you have to use them, or you can go to a different network. And the things that are not, we need something else. And PVD could be that.
Yep, exactly.
Actually, Lorenzo, since hi, it's Paul. I actually tried to set up a IPv6 network. Don't laugh. And so as I was going, and this was greenfield for me, believe me. So I started seeing some things with PVDs. Can you talk a little bit, because this group might believe that there's a network other than just V6, about status of PVD? Is it available?
I see Arthur's in the room.
Well, you're at the mic. You're at the mic. So just for those of us in the V4 world, can you describe?
I think like a 20-second summary, it's possible to have more than one network on, more than one sort of realm in a network. And the PVD is defined as a consistent set of configuration information, and you could have like Comcast and AT&T on the same link with two routers. So those would be two different PVDs. You can't use you can't use the AT&T AP address to talk to Comcast because they'll drop it. You can't use the Comcast name to resolve the AT&T only specific billing gateway host name. And PVDs are a way to separate those, and they're identified by David host names. Is that right? Sort of. FQDNs, yes. Okay. And yeah. No.
Great.
And yeah, I mean, go read the draft. It's useful.
This is in which working group?
Interior, I believe.
Great.
Yeah.
Yep. Okay. Thanks.
So, Warren Kamari without any hats.
Oh,
this time for sure.
I'll wear it.
So yeah, I mean, ideally, I would prefer not to get my security stuff handed to me via DHCP. But if the alternative is between that and just not getting it at all, I think this is still a little bit safer than not.
Right.
Also,
sorry, go ahead.
Oh, sorry. Also, on many networks, like the network we're currently on, it has to be somebody who's actually in control of the network, who's able to send DHCP responses. Like most switches now, you can easily make them block that. Our Wi-Fi network, for example, doesn't let you send DHCP responses. So at least it kind of somewhat narrows down where your attack surface is. And even if I'm kind of doing trust on first use or opportunistic, at least there's still some encryption, and so the dude next to me can't see my queries.
So I've heard that argument before. I don't know how much leeway you want to give me on diving into this.
I would. Answer, but don't take a lot of time, because actually, sure. I think many people in the room believe that you believe DHCP sucks.
Well, that's not really my point.
And by the way, I believe other people believe it as well.
Yeah.
So, yeah.
Yeah. No, the point that I have is that actually using DHCP to configure something with security properties that you care about has the potential to create a new attack surface. It's not merely that it leaves an old attack surface. It's that if you land on a network where for some reason you can't get to the DOE server that you normally go to, and your DHCP server gives you a new one, you definitely shouldn't use that network.
Yeah.
Like that's evidence that you're on a network you shouldn't be using.
Yeah.
So.
Yeah. Eric Klein, that is kind of a matter of policy, though, right? So, sure. If you had no other options, in order to use a different DNS server, you'd need to have some policy that says to prefer something else. I mean, by default, every single person's, unless you've manually configured some override or you're running stubby to some dedicated service, you're just going to use the name servers of every coffee shop you ever connect to.
Right.
So actually, I'm going to cut the line, Mike, just on that, because I didn't realize many people would run up.
We created a strict mode in the private DNS feature in P, where you specify the host name of the service you want. We bootstrap with the name servers on the network, just like you would use the name servers on the network to find Amazon.com. We bootstrap to find those IP addresses, talk to it, TLS validate the host name in the cert. And if we can't do that, we put a little X and we don't move the user's traffic over there at all.
That's what I'm arguing for.
Yes. And there's also a whole lot of other probing going on when a device joins the network. There's captive portal probing.
Yep.
And so adding TLS probing and DOE probing into the mix may not be too much of a delay.
Yeah. That's all I'm asking for.
Yeah, Joel Yeagley. So I find it interesting that I have to sheepishly explain in 6-man V6 Ops, IEPG, elsewhere, why it is that I don't trust the networks enough to use them for bootstrapping. But I'm directly exposed to this problem. So, I don't trust DHCP. I don't trust Slack. I don't trust DHCP v6. And the vast bulk of the information I can get, I have to pass via upper layer protocols after I've done some kind of minimal trust insertion, typically on a management interface that's on a network that I really carefully control, because the tool is not expressive enough and it's not good enough that I can actually trust the information I receive from it. So, like yeah, I mean, this is a problem we're exposed to.
Mike Bishop. Oh, that's quite loud. Okay. I wanted to just comment that what Warren said about network hardware being able to filter out DHCP responses, yes, if you, some hardware being able to do that. If you trust the administrator of the network and know who that is and are sufficiently confident that's the network you're actually on, then great. But I also know that there was an attack, I don't know, 2 years ago, where you could stick a little USB device into a computer and it would claim to be an USB Ethernet card on which the DHCP server gave you the address for a proxy, and that proxy would ask for your corporate account credentials. And old versions of Windows would say, oh, I'm on a corporate network, I need to authenticate. And you could steal the password from inserting a USB device that was actually a malicious network. And you can't trust the network at all. And I think it's kind of the problem we're dealing with in Quick. Why can't we hard authenticate the version negotiation? Because we have no shared key at that point. And you're in kind of the same boat with DHCP. You have no shared authentication mechanism with the network when you first join it. And yet you have to trust it, and we haven't found a good way around it in however many decades we've been doing this.
Thanks. So, Tom, do you even want to give your next one since it's about DHCP? You're welcome to. I'm just, oh, here, wait. I need to mouse over to here.
Let me respond to some of this, and then we can decide if it's worth it. Because, I mean, you can read the draft. So the idea, I mean, not all, you establish trust in different ways with different people, and not all the time would a DHCP option be the right option. If you're in a coffee shop, you probably want to ignore it. If you're in your corporate network and they want you to use internal DNS because internal DNS has all the things you have to access when you're inside the corporate network, you are going to use the internal DNS, and you don't have an option. And if they can make that be encrypted, well, that's a good thing. So there are times when it's appropriate. There are times when it's not appropriate. If you want to do it, if operating system vendors say, we know these 10 public resolvers are good, and we're going to put those in the operating system when we ship it as a whitelist, and anytime you get a DHCP option for a TLS server, DNS TLS server, and it's in that list, we'll install it in the, and use that as a resolver. And if it's not in the whitelist, we won't. So there are ways to make it better, how the trust that you have in it can be increased based on these things. If you have a certificate that you verified to the resolver, if you have a TLSA record for that, that's DNSSEC verified, then that says you won't, you went through a lot of trouble to make that resolver seem legitimate. And depending on where it is and when, that might be enough. But the trust is different in different environments.
So do you want to do, because your presentation, it does have lots of good questions in it.
Yeah, that would be good.
Go for it. Actually, Ted, I assume you were answering his universal questions. Why don't we jump down into solution space and then pop back up in a bit?
Okay. Okay.
And you can skip over the DHCP option. That part of it.
Yeah. Okay. I'll do this quickly. So a couple, just warning, we did IPv6 because we had more flexible option space, and we wanted to try to come up with the best solution we could. We plan on going back and doing v4 if this is something people want. We're not, wed to this idea, and we could certainly just drop it and delete the Git repository. So why encapsulated options? Well, they're flexible. They let us do the sub options in any order, and we can have as many of them as we want. And so we don't have to deal with lists. And lists imply order, and we didn't want to imply order. So we decided to duplicate the outer encapsulation option because order didn't matter and it was simpler that way. Let's see. So a question I have is there is already an IPv6 address option. It allows you to have a list of addresses. That's nice. We probably want to add that to ours because I understand Quad 9 has a list of addresses for a single name. But the current option implies order. It says that you try this one, then this one, then this one. And we don't want that. We want it to be in order independent. So if we use this option, are we implying order? We could say that we're using this option, but we're not implying the order. And will people understand that? I don't know. Or do we just do another one? I'd like feedback on that. Let's see. You might ask why we didn't have an option for this SPKI. Well, it's the trust thing. If you were checking the certificate with the same person who sent you the address, then it doesn't really give you any advantage. And there was questions on the mailing list about order, and people wanted the guy who responded wanted order, and just from Willem's experience with Stubby, they would like the flexibility to be able to try different servers and not be restricted by the order. The fact that you can't change the options, but maybe once a day or whenever you get a new update means that they're essentially static. So we don't want that to be to imply anything. It's more flexible if it doesn't. Same with the preference or priority. So that's it.
Let's not do the is DHCP a good idea one again now. By the way, it looks like we'll have plenty of time at the end. And I'm not saying let's put a kibosh on DHCP discussion because I think that that's central to one of the reasons why the BOF happened at all. But maybe we can collect them at the end, especially when Sarah has talked to us about security stuff. So, but for now, please. Yep.
Hi, Pat McManus. So if you're going to do DHCP for this, we'll just leave that off the table. I read it with respect to thinking about Doe. Seems mostly cool. The URI option should probably be refactored to be a URI template, which is actually the configuration primitive of Doe. And then you can remove all that text about how you process get and post and just leave that to the other spec because it's a little bit wrong. But if you just make the template, the Doe spec will take care of the processing there.
Okay, thanks.
Lorenzo Cuddy, I mean, I know we said we were not going to bash DHCP, but did you?
but you're at the mic, so go for it.
But do you envisage ever needing to change this? So like ever needing to change the IP address or anything else? And did you have a plan for that? Because depending on whether it's stateless or stateful DHCP, there's not, if it's stateless DHCP, there's not even a server push mechanism of any sort. So if it's stateful DHCP and so it's tied to an IP address lease, then clients might support reconfigure. I don't think any do, but that is actually an operational consideration, particularly for network where your upstream is moving. Like if you have a hotspot, you have to change your DNS server IP addresses.
Yep.
Paul Wouters read it. I still think this whole problem space is just about all the problems of the captive portal and getting a clean network. And once you have a clean network, you have your known trust anchors already, and you have clean IP towards those trust anchors, so you can just use them. If they're giving you, even if they're securely giving you a privacy secure server, why should I believe that they're privacy secure if I don't trust the network? So I don't understand all of this work, actually.
Yeah, that's perfectly fine. If we decide this is not the right thing to do, then we'll walk away, and that's okay.
Or run away. So, thanks. Mark.
Do we have a clicker? Or?
You do. Well, I have a clicker. Would you like a clicker? Please have that clicker in specific.
with lasers.
I do that, and I think you are good to. I
Go.
think you're good to do.
I'm good. Oh. Boo. So this is a little bit different. This is after some discussion amongst folks, an idea kind of emerged, and I wanted to walk through it just to see if there was interest in pursuing it. I will say right up front, my DNS foo is fairly weak, so please don't judge me. And there is a certain amount of rapid hand waving to this, but it's more about, is this a direction that's interesting to go in than about the particular technical details. Just to recap, when people worked on, I'm going to get away from the mic a little bit. When people worked on DOE, the goals, at least for a lot of the people involved, were to improve privacy and censorship resistance. You want it to be resistant to on-path changes, so it's encrypted. You also want to make it so that it's harder to discriminate your DNS request traffic from other traffic, so you lump it in with a bunch of HTTP traffic. And that way it's harder for it to be blocked. And so if you're looking for those properties, then you need something from a DOE server. You need it to be high traffic, so it's easier to hide that traffic amongst the DNS queries, amongst other things. Ideally, you want it to be popular so that if someone somewhere does want to block it, they have to kind of think about it before they do. If you just use a dedicated DOE connection, for example, then you just block that, and that you can discriminate against it. But if it's hidden amongst one of the world's most popular websites, for example, then that's a much more weighty decision to block it. And finally, you want it to be reasonably distributed. You want it to be served from lots of places so that it's relatively close to the client and high performance and so forth and so on. And once you kind of say, okay, those are reasonable things to look for in a DOE server, it becomes pretty obvious that you want to co-locate your DOE server with big popular websites or CDNs. These are meeting all of these things. And in fact, the one that's being used now for testing is a CDN. Stop playing, Paul. So, Paul.
That was the mouse. That was the. Oh,
I think you have to press the button up the top.
Ah, well, see, I wasn't pressing the button.
No,
you're
try
wrong.
again. All right, back away. Okay. So how do we encourage those big sites to serve DOE, to serve this function? When you think about it, it's not a one-way street. Serving DOE doesn't just have benefits for the client, it also can have benefits for the server because it is co-located with that HTTP traffic. So it provides more privacy for the HTTP, the clients of the website that's serving it, not only for the DNS queries, but also for the HTTP queries, because there's one less party involved in communication. If I'm using his DNS server to get to her website, well, that's two other parties that are involved at a minimum. If I get the DNS from her as well, it's one less party. That's nice. And I'll skip down to the bottom here. That likewise has a reliability impact. If there's one less party involved, then that's one less dependency that we're taking. And depending on how the architecture of what you're actually serving, that can increase your reliability. There was an interesting paper very recently, conveniently published for the purposes of this talk, although I didn't publish it, which explains this, how you can have, when you have dependencies for CDNs and DNS providers and stuff, split amongst different things to serve a website, you have more points of failure to consider. And finally, and perhaps most interestingly, is there's a performance benefit. Because the HTTP client is the DNS client for that site, if it's served off of the same HTTP server, you can take advantage of the information to figure out where the client is located, but especially you can use things like secondary certificates, which is what we're talking about in the HTTP working group, which is built on some work in the TLS working group, to shove certificates down to the client so that they can aggregate and coalesce all those origins onto one connection. So not to dive in too deep, but okay. We've got time? Okay. So normal HTTP, you make a connection to a website based on, you do an DNS lookup, make a connection, and you go off and you get whatever you want to get on that connection. HTTP2 added the ability to coalesce connections. So if the certificate covers two different origins,
and you have a connection to that one, the IP address for one of those origins open, you can use that connection according to a set of rules, which I won't get into now, for the other origin, for example. And so you're now putting the traffic for two different sites onto one connection, which has benefits in avoiding connection setup. That's an obvious one, although it's becoming less important because we're starting to do things like zero round trip. But less obvious, when you use only one connection or a fewer number of connections to load a web page, you have a nicer time with congestion control. When it's very common on the web today to open 15 or 20 or 30 or 50 connections to load a web page, and you have, as a result, a large number of servers slamming data down at you all at the same time, and that causes congestion. It overcomes TCP's congestion control mechanisms because it's uncoordinated. If you do it over fewer connections, that means that it's more coordinated and you have a better time from a congestion standpoint. So this is a very desirable property. And so if you want those performance benefits, you need a way to get all of those different diverse connections coalesced down. Secondary certificates is one way to do this. It allows a server to push a certificate or proof of ownership of a certificate down to the client, and the client can use that to say, okay, I know that they actually are authoritative for this particular origin. I can send the requests on this existing connection that I already have. One of the problems with the secondary certificates is, when does the server send that certificate? It needs some information about when is it appropriate to send a certificate that I hold so that I can actually get some performance benefit on this particular connection. There's no obvious way to do that. If you're also the DOE server, however, for that origin that you hold that certificate for, the DNS request stream becomes a perfect hint for that. The client looks up a particular name, the DOE server gets that name, and it says, okay, well, here's your response, and oh, I've got a certificate for that name too. Here you go, and now you can use this connection for that origin. And so that's quite interesting. So these are potential benefits that a server might want to think about when it thinks about hosting a DOE service. So that's background. Currently, in the current landscape, the only way that you can configure a DOE server is to do it in the client. Let's say, for example, a web browser. You go to Firefox and you select, yes, I want to use DOE, and you configure the DOE server. They've put in one that they suggest. I don't think we have too many others right now. And it uses that DOE server for anything. And so only that DOE server gets these potential benefits that we talked about back here. It would be nice if we could use those benefits to create an incentive to share out and create more DOE servers. If you can select the appropriate DOE server for a given piece of content, then you're sharing those benefits out amongst those DOE servers, and now there's an incentive to create more DOE servers in the ecosystem. Ted, do you want to wait or do you want to talk? You seem very pensive.
Ted Hardy, Google. Two questions that are clarifying, and then I probably have some comments later. But the clarifying question is, historically in the DNS, we've had this distinction between an authoritative server and a recursive resolver. Mm-hmm. And in this particular case, what you appear to be heading for is something which is kind of neither of those in the historic sense, because what you want to say is this is willing to provide information on a set of, but not all, back-end things. And so
I did not say that, and I have not made a proposal yet.
Okay, so let me ask it as a different question. When this DOE configuration mechanism has one configured server and gets more, are those considered to be equivalent recursive resolvers using DOE?
Can I get to the next slide?
Sure. Okay. See, you called me up early. I was.
Oh, that's very true.
I was back there, kind of waiting.
You just looked very pensive. I didn't want to make you wait. Sorry. Clarifying question?
Yeah. Yes. And then I'll get back in line.
But you have to look pensive.
I'll look pensive. Wes Hardiker, ISI. Just so you know, your sales pitch to date, the way I read it is, oh, yay, we finally standardized obscurity through subscurity. And I even got that backwards.
Keep going. We're waiting for the next slide now.
Okay, I don't know how to process that. I'd love to talk to you about it, though. So one way, and this is what the draft goes into, one way that you might address this problem is by having a DOE client have pre-existing relationships, okay, with multiple DOE servers. So right now, for example, Firefox has a contractual relationship with Cloudflare. It says, will you be my DOE server? And they agree about privacy. They trust Cloudflare to have certain properties, and it is a generic DOE resolver. It's acting as a resolver. It's not specific to Cloudflare stuff. If Firefox, for example, had more relationships just like that, where they trust a set of partners to provide DOE service for their application, you would need a way to select the appropriate DOE server for a given host name that you're looking up. And so one way you could do that is to have each of those partners send a Bloom filter on a periodic basis to the client that could be used to select an appropriate DOE server. Now, of course, a Bloom filter has false positives, but if each of those partners is acting truly as a resolver, that's okay. It'll fall through, it'll get resolved, and you get your name back, your address back, rather. But it gives you a way to direct traffic at scale. So that if I have a relationship, if I'm an application, I have a relationship with 5 or 10 different DOE services, I can know that if I send this query to one that matches that Bloom filter to its associated DOE server, now, is something funny? Ted's now looking beyond pensive. Okay.
This is still in my pensive range.
Okay. Tell me when we remove ourselves from pensive into something else. Then you can direct the traffic, oh my God, to the right way. Why is this a proposal? And again, this is very hand-wavy. I wanted to start a discussion, and I think we've succeeded. Why a Bloom filter?
The minutes taker notes the wide variety of people in the line, like one from every topic.
We're all going to indicate our support.
Sure, cool. I get that. Yeah.
Mark, why a Bloom filter?
So why a Bloom filter? Is it easier just to go around the room in rows? Why a Bloom filter? Because you could say, well, we'll just send all the host names that this DOE server is interested in. But some of the use cases, for example, large CDNs, AWS, Google have a large number of host names, and it doesn't become practical to shoot those. Shh, gentle. It isn't practical to send those lists out to all the clients every day, for example. You need the update period to be frequent because you need to accommodate changes, and there are potentially a large number of clients. And again, false positives are okay in this model. A lot of open questions about this, obviously. I think the very high level question here, and probably the most important one for the people so thoughtfully in line to address, is thinking about DOE in this way a good thing or not? Thank you. Wait your turn. Is prior arrangement the right discovery mechanism? Is a Bloom filter the right protocol element to be using for this situation? Lots of other things as well. Yeah, let's go.
No, you can get first. I mean, you positioned yourself correctly. So I read the draft and I misunderstood it completely. So let me just start.
That's my quality as an author right there.
I misunderstood it completely because what I thought you were trying to do was to give the opportunity to allow somebody to have prior arrangement with 2 different DOE servers that served potentially different scopes. So for example,
absolutely not. No.
If what you were doing here was saying, hey, here's a Bloom filter that tells you all the things that are within your enterprise network, and this is the DOE server to talk about for that, and this is the set of things which are globally scoped, and you can talk to any of these DOE servers for that. That's where I thought you were going. So I looked confused in part because I completely misread your document. And so I apologize if that was sort of an upsetting amount of like rejiggering my worldview as I looked at your slides and heard you talk. That said, I think this is a terrible idea and it should die instantly.
There you go.
In part because I think prior arrangement in this case
you're trying to take this prior arrangement and bootstrap it into a set of trust relationships that are based on something that I don't actually think are necessarily the trust relationships that relate to the DNS at all. What I think we're looking for in this case is actually people who are going to provide answers through the DNS over HTTP to a full spectrum of queries, and which are then checkable, right? That they're either DNSSEC or they're to a trusted party. And you're chaining that trust in a way that I don't think we have any experience with, and I have no reason to believe would actually work. And worse, there is a real risk here that, one, your point about in the draft, discovery of how to get the first of these digests is left as a recursion to the reader is realistically a problem, because it's a way of directing traffic to people who may not be able to handle it or willing to accept it. Right. So if I can provide a digest that says, go talk to those people and ask them these questions, I can actually flood traffic to them in a way that's quite seriously a problem.
Sorry, can you repeat that?
So let's say I send down a digest that says, oh, by the way, here are my friendly other people who will also accept your queries, but I'm not actually trustworthy and they don't accept your queries or can't handle the number of people.
That's not what I'm proposing. That's not possible in what I'm proposing. You can only attract traffic, you can't repel it. That's right.
Okay, but if I send a Bloom filter,
let's say, for argument,
I'm sending a
you're
digest.
Google, and I have a relationship with you.
Right.
Prearranged. A trusted relationship.
Yep.
You send me a digest. It contains a hash, a digest of a number of host names.
How do you know they're mine?
Yes. That is the question. And that's why I was asking these questions. Whether having a prearranged trust relationship is good enough.
No.
So, right, and okay, I'm glad we got here. So right now, when I spool up DNS, I trust that my network's going to give me a resolver, and I'm implicitly trusting it, right? And when Firefox starts up, it's a...
Wait. So
mic line or quiet, please. It's extremely distracting. I trust my network with DHCP, right? Firefox right now is trusting Cloudflare based upon a contract. If we want something else, I'm totally on board with that, and we can talk about that. But this has roughly the same properties as those do. And yes, we should do better.
So I'm saying that if you have prior arrangement, what you're doing in the first case is saying, it's like pre-configuration, right? I have a prior arrangement with you. Firefox has pre-configured Cloudflare as my recursive resolver, right?
Right. And they have a legal relationship backing it up.
There's a basis on which they've done that. Right? At the moment they did that, all they were able to do is, as was pointed out by the line, is bring traffic to themselves. And that's what this does.
Yes.
Is add the ability to move from bring this traffic to themselves to direct traffic to any place they name.
No. That's not part of the proposal.
Then how can they add anything in that's a new DO server?
So, try again. You're Google, right?
I'm Google.
Sure.
I send you a whole bunch of host names. How do you know they're mine?
I don't. I have a relationship with you that says you're going to act. Imagine the contract that Firefox has with Cloudflare, right? We have the same contract. They don't know that Cloudflare is going to send them the correct names.
Right.
Right.
But at the moment, sorry, I'm going to get out of line because there are a lot of people behind me.
Apparently.
So I believe that what you've done here by taking the first discovery mechanism that's prior arrangement to a single host and expanded it is to enable that trust relation to shift from I'm going to send you DNS queries to I'm going to send you DNS responses, and oh, by the way, I may give host names to you to which you may send DNS queries, and that's a different relationship than we had before.
I'm not sure I'm understanding you still, and I'd really like.
I understand. But Wes, hold on for a moment. I said at the beginning of the meeting that I suck as a BOF chair. I'm about to prove that. Who in line wants to say something significantly different than what Ted just said?
Well done, Paul.
Okay, so the reason why I asked that was I thought you all would look introspectively and say, no, we're all going to tell Mark that he's full of crap and sit down. They're
going to tell me I'm full of crap in different ways.
Well, okay, I'm sorry, I didn't express significance strongly enough. We have another presentation from Sarah, you're up, which will come soon, and it won't come soon if you're all in line. For those of you who weren't at the IDS conference last Friday, she will say some things that won't be quite as challenging as Mark, but still should bring up interesting issues. We can keep the line going if you want to yell at Mark. Remember, this is not a working group forming BOF. There's, we can argue this on the list. Mark might just give up, and I'm okay to leave the line, but I'm just saying that there's another presentation that is broader than Mark's suggestion, but will still be very, very challenging to some people in the working group, and I think it would be in the BOF. I think it would be useful. So, Warren, are you going to?
Just as a suggestion, instead of the question you asked, maybe, is there anyone in the line who is supportive of the idea, which I think is a slightly faster route.
I see one hand. Wait, these are a bunch of people who are supportive? Wow.
They may still think I'm horrible.
Ben, I'm going to ask a really obnoxious question. Are you lying? No, okay. Okay. How about one more, Mark, you're insane, and two, Mark, you might be onto something, and then we go to Sarah.
Or who can be quick? 30 seconds each or something.
Okay, so let's just do the line. Sarah, are you okay with us punting on? Okay, and again, I just want to point out, I've seen Sarah's talk. Some of you have, but most of you haven't. And it is actually challenging in different ways. So okay.
I think Sarah's enjoying the entertainment value here.
Yeah. All right. Wes Hardiker, ISI, along with my 20 friends, reservation for 20. I'll try and keep this really fast. So predicting 30 years in advance, based on the model that you've laid out, every web browser is going to have a contract with, like 500,000 corporations that all want their own DOS server, of which they are going to cache information for an indefinite period of time, and until it doesn't work, at which point they will fall back to some basic DOS service, and they are going to start sending all of the material you want up ahead through the DOS port instead, like certificates in the secondary certificate kind of thing. So, wow.
So Wes, I disagree with where you think it's exactly going to go, but I think you're asking exactly the right question: is what kind of ecosystem is this going to form, and how do you put the right incentives in place? And that's a great discussion.
Lorenzo Colletti, prior arrangement between who? I'm the user of this thing. Do I get no say? Like my browser. Ted's earlier point. If I can prove that those host names are mine, and you would have hit the root and come to me anyway, sure. Anything else? Change from existing behavior. You need to be careful about privacy.
Sure, agreed.
Ben Schwartz. So yeah, I generally think this is a pretty cool direction. I think it's interesting. I think mostly the Bloom filters confused a lot of people, and I think it's entirely separable. I think that ultimately you're talking about connection coalescing heuristics, which already exist, and this Bloom filter is a connection coalescing heuristic that could totally be addressed as a separate and interesting HTTP concept.
Right. Just to give an idea, one of the discussions, and I forget who suggested this. If you're in the room, put your hand up. Someone suggested using an HTTP response header from the server to say, "This is my DOS server." That's a completely different mechanism of discovery and communication. You're basing it on the authority of the TLS certificate. I'm open to a lot of different ways to do this. I think we just need to examine the properties. But you're right, the Bloom filter perhaps is a bit distracting.
Jari Arko Eriksson. This is fascinating technology, but I'm actually concerned that your prior arrangement model is going to lead into undesirable things in the ecosystem, as you already sort of were asking about that. And I'm not sure we're going to have like 500,000 different servers, but rather that we have just a few in the world. And that, I think, is a harmful direction for the internet. That's why I'm concerned.
I had the same consolidation thoughts. Let's get the C word out there. I think that balancing that with encouraging these very large high traffic networks to serve DOE is a nice privacy benefit. And I'm a bit this about that too. And that's why the HTTP header one was so intriguing to me, because it kind of democratizes it so that any site could serve itself, its own DOE.
Any site could, but in practice, few will. But yeah, I mean, this is worth discussion.
David Skenazy, Apple. I wanted to start off by saying that this is insane. Except I like insane, because this might actually work. My main problem with DOE in general is right now there's this massive master switch where I'm either telling everything to Cloudflare, I need a complete arrangement with them, or I'm sending it over the regular thing, which works better if there are things there, but it's completely insecure. This might be the way, or it is at least a way, to get a middle ground. And sure, there are a lot of dragons in here that we need to be careful with to make sure that people don't grab all the things they shouldn't, but we might be able to make this work. So thanks for bringing this.
Thank you.
Pat McManus, Firefox, thank you for the product announcements. I appreciate it. Okay, so Lorenzo's comment about user config. So this is really in the absence of user config. I mean, I think that's like a first order item. If we actually get input of someone who has a plan who's operating the application, like that's awesome, but that like never ever happens. So this is like what you do as the next step, right? When we talk about privacy and the trust models here, right, this is really like when we did our contract with Cloudflare, a really reasonable summary of that is online. It is all about privacy and data handling. It's not about them giving correct DNS answers, because they are a recursive resolver and it's limited in scope into what they can do. But our trust relationship says what they're going to do with our users' data, which is absolutely nothing, and throw it away. And that's what gets, that's what gets enforced by that agreement, right? And I think something like this is probably one tier in a good model, right? So the really nice thing about this is it breaks up. I mean, I don't like the centralization of the way we've done DOE to start with, but having one server is super centralized, right? And making this a tiered step where there's a set of them is a great step forward. And to the extent where we did get into a lot of HTTP2 inside baseball there in your presentation, but to the extent where that stuff works, you keep data co-located at both a DNS and an HTTP level with the same servers who see and use that. So you're not spreading this information throughout the network. That's also a truly awesome goal. I think there's some things you can do around hash models and some other things to deal with the default cases. And I guess the last thing I'll say is there are actually probably policing mechanisms. If you have a trust relationship with these organizations, you can get like a Bloom filter, for example, would have a predicted rate of false positives. And so the amount of times they're not able to provide a HTTP level attestation of an origin, if that does not correspond with your rules about Bloom filters, could be like an input to policing. So there are some interesting mechanisms here.
So Martin Thompson, I mainly just got in line because I thought I might need to. I didn't have anything to say when I joined. One of the things that I
thought
just
HTTP2 push. Sorry.
No. So I think the genesis of this is this idea that we suddenly have this configuration for a single DNS server. And to Patrick's point, you don't see very many people changing configuration. So we have one server that gains every single DNS request that we ever make. And the idea that Mark has here would allow us to configure multiples and share them without necessarily sending all of the traffic to the wrong server when there was potentially the right server in that set. The amount that this privileges those people in certain ways is something that makes me a little bit uncomfortable, but that's something we should talk about.
Yeah.
I did realize that one of the consequences of a design like this, and I realized that the Bloom filter was just a straw man, but it tends to make the set of names that a particular host provides enumerable in certain ways, and that's not a property that I think we want.
Yeah.
And we would want to find something that has sort of the inverse properties of the NSEC 5 or something along those lines. And
I realize I'm probably trolling the DNS people right now.
But that was a good one. No, that was definitely a good
that's
one.
the idea. That's the space that you need to be thinking about as well.
Yeah, thank you.
Just a quick question. If you had seen this line before, would you have switched from Bloom filters to that HTTP header?
No. I think we need to talk about the properties we want out of it, and that's a great straw man to start with. Right. Yeah.
Okay.
Eric Niagara Nakamai. I think we're, as we've seen from some of the presentations, they're kind of stuck in a weird situation here where we're between, we don't want to trust the local networks, DHCP servers, but we also don't want to go to a point where clients just go and pick a single centralized server, because then we've centralized everything, or we've made it a decision that is entirely up to the people writing that client software. Like, it seems like one of the properties we'd really like to get to is back to a case where the whoever controls the domain that you're looking up for the name for has control over that transaction and is responsible for providing the security and privacy and whatnot properties around that. It seems like if you step back from the implementation details of Bloom filters, there may be, and look at and kind of step back to what are the properties we're trying to get here? How do we build an ecosystem? You could see things in an ecosystem which has properties such as some set of those servers as candidates with a way to become one of those candidates, but where you'd have to, but where there might be some common agreed upon bars you need to do that. So, for example, in the certificate space, it's not great, but we have if you want to be a certificate authority, there's a set of criteria that specifies this is what you need to be if you want to be a CA. So if we had something similar for what you need to be to become a DOS server, and then I think another important property, which some people have alluded to, is you need to have a kind of open, transparent, and scalable way to add yourself to that list. If you have a domain example.com and you want to bind example.com to a particular one of these trusted DOS services, there needs to be some way to do that that's under your control, such as some form of domain validation. And then I think a big kind of, if we go down a path in this direction, then a lot of it just becomes the hard problem. It ends up becoming, how do you actually scale this thing in a way? Like, Bloom filter is one way to scale it, but it doesn't really scale and has some property of its own. We could go and look at building a hierarchical service for managing names. Oh wait, we just, I think we have one of those.
At least one.
At least one. So, but I think the direction is interesting. So I think if we take a step back from the implementation to the how do we get there, there's a lot of interesting stuff here.
Yeah, thanks.
Mike Bishop, I will second a lot of what Eric said, but frankly, the change from having to trust Comcast with all of my browsing traffic when I'm at home to having to trust Cloudflare with all of my browsing traffic all the time is not entirely an improvement in my view of privacy. And so if there was a way that I could partition it so that nobody got a full picture, and particularly even Google, so that nobody got a full picture of what I do, and in order to do that, you would want, anytime I go to a particular site, probably to use the same person, so you're not sharing it with more resolvers than you have to, which implies there has to be some way of partitioning them consistently.
Right.
And if you're going to partition consistently, then trying to also squeak a perf improvement in seems like a lower priority, but still worthwhile thing to do if we can do.
Well, I'll push back a little bit. I mean, if there were multiple DOS servers out there right now, Firefox could consistent hash all of them out, and we'd be done. This is a little different, because even if you just consistent hash them out, you'll still go to Cloudflare for one that's hosted by Akamai. With this kind of approach, you go to Akamai to get one that's hosted by Akamai. That's the big improvement for privacy, performance,
That's true.
and
that is
reliability.
actually a privacy improvement.
That's what we're looking for.
Yeah. Fair enough.
And it also, at the same time, gives Akamai an incentive, for example, to actually host one.
Right.
It's not a winner-take-all market anymore. That's what I'm trying to create, is a broader market.
Yeah, so I agree that the incentives you're driving toward here are good. The proposal itself has some negative properties that we want to sort out, but I like the direction.
Thanks. The proposal is mostly to start the conversation.
Eric Pasquale, I'm shocked to see this proposal. Shocked.
Thank you, Actor.
Seriously, I mean, we're looking at how we got here, right? Which is that we started out with like the fact that, let's just say that the recursive resolver you're given often is like not acting in your best interest. And so, there was some thought that perhaps one could get a recursive resolver which would act in your best interest. And then, of course, that centralizes everything. So like that's not necessarily ideal. We have to compare. So like when we discuss this proposal, we have to compare it to like those alternatives, neither of which is like ideal, right?
Sorry, that was too much echo.
Sorry, when we discuss this proposal, we have to compare it to those alternatives, neither of which is like entirely ideal.
Yes.
So I mean, for me, when I evaluate this proposal, this isn't about FOMO on the part of like Cloudflare's competitors. It's about like what's good for for users of Firefox or some other product, right? And in the ideal world, right, the process of resolving the name would not leak any more information than using the name itself. And so in an ideal world, either I'd have an oracle that gave me like every information, or I would get that information from exactly the person who I was then going to contact, right? That would be the ideal world. And so how do we get close to approximating that? How do we build that, that oracle? So sorry, I had some notes here. So like this seems like an attempt to get near that. I don't think it's a perfect attempt. I think that maybe it's maybe worth trying to distinguish between two cases, right? One case is the set of people who, are actually the sort of the server, the authoritative server for the domain that you're trying to reach. I don't want to use, I shouldn't use authoritative, that's a technical term. The people that are like where you're eventually going to end up going for the domain you're trying to reach, and then people who you otherwise have some, who otherwise are just serving as a default backup, right? So, my thing is hosted on DreamHost, maybe DreamHost doesn't work recursive resolver, so I've got to get that somewhere, right? And so that's how you end up like a Cloudflare or whatever, right? So, probably it's worth distinguishing. And so in your proposal, the reason these are coupled, right, is because you're trusting is to some degree because you're trusting these people not to lie about which domains are assigned to them. Namely, that you could imagine a world in which I had a list of, these are the exact domains that Akamai hosts and the exact domains that Cloudflare hosts, and then my backup is like someone individual, right? But that part of why you're like, I have to and in that world, I wouldn't need any kind of special relationship with the people who were resolving the domains I cared about because they wouldn't be able to, because I know for a fact who they were, right? And so the reason why you need the relationship is because you want to trust them not to lie to you about that for enforcement purposes. Right. And so it's probably worth dividing those things up a little bit and figuring out what our threat model is for these people, and how much lying we expect them to do and how much enforcement we expect to have power to have over them and those kinds of things. And that's a troubling problem for IETF because IETF isn't used to having this kind of contractual arrangements. Yeah. But I think you're right to think that that's where it'll have to go to make this viable. But I think the way I think about this problem is what is the most efficient and secure way to build that Oracle question and that box, and and that's where we get the HTTP headers versus Bloom filters or whatever. But I certainly think it's interesting to try to build that. If we can build it, it would be another iteration of improvement over the thing that we like to have now.
Right.
The two things we have now.
And in some of the discussions I've had with you and with some other folks about this, it's like, is this going to go towards like a CA browser forum style interaction, or what kind of ecosystems can be built around that? I think that's we need to think out that far. And I'm starting to suspect that it's not just one mechanism. We probably have
quite possibly, yeah. I guess I would say I'm actually much less concerned about this enumeration problem. It's just like not that hard to do the enumeration. So it may be the case that I'm concerned about that for accuracy purposes, but I'm like, if I had to build a system that forced that had the good properties we're talking about, and the only negative property was that it forced like everyone who wanted to play to disclose the domain names that they were like responsible for, like that wouldn't bend me out of shape in any way.
Right. So some sort of CT kind of mechanism almost, or yeah, okay.
Hi, Mark.
Say your name. Yeah. Is this your
first of all, you're a champ. Yeah. Has there ever been a plank that comes up to the microphone? Has that ever been a thing?
So you didn't actually say your name.
Humameshdi, I did. I'll do it again, though. It's fine. I want to answer your original question, which is this interesting? And I want to do it by amplifying what Ben said, which is there's two different things happening here, and one of them is being super emphasized, and it's not surprising considering the room. And that's the distribution of the information. So if you separate the distribution of the information from what's actually happening technically underneath, which is a content distribution network, for example, is getting directly asked the DNS question from the client, which has significant performance benefits on top of what you outlined earlier, we've always wanted to not make routing decisions based on a resolver. We've always wanted to make decisions based on the client, and this enables that. So that part of it is super, super interesting, and I would imagine that all the other CDNs in the room are saying similar things. The distribution model obviously needs some more thought. We have a multi-CDN issue we need to solve for this to happen, but at the core, there's something technically there to continue to talk about. So I think there's value in it. We should definitely figure out the bits and pieces and definitely rethink the distribution, but there's definite value in it. That's it. Thanks.
I'm the last person in line. Subodh Iyengar.
Well, except I see a couple people lurking, thinking to go up for seconds. I see Warren looking like this.
Hopefully nothing I say will trigger. Subodh Iyengar. So one of the other aspects which I didn't see being brought up was of the benefits of something like this or this direction is the incremental deployment nature of it. So some services would want to run a DOE server, but in the process of deploying it, they want to only restrict it to themselves first so they have the time to build it out. So you'll get people out there faster, at least having DOE deployments. The other aspect of this was that we are having some of these trust conversations in other scenarios as well. For example, origin frame and secondary certificates. So when I see this and so the future, envisioning it as a CA browser forum kind of thing, I'm not so enthused by that. I think that's probably the only practical way to do this, but I'm not super enthused by that. I would much, if that's the only way, then that's fine. But I would much rather have us actually make decisions, hard decisions on those other conversations so we can feed that back into this approach and say we have this clear-cut set of rules by which we prove ownership of the domain and going to the HTTP header route of each domain owns its own resolvers and stuff.
All right, thank you. Paul, can I ask you as our BOF chair,
Just go for it. Ignore me.
So how should this discussion continue?
How would you like it to continue?
I think I'm going to ask for a mailing list. Does that make sense?
Well, so we have the DRIU mailing list, and we could do a separate one. I suspect that this is actually still conceptually tied to some of the earlier discussions of getting things through DHCP, because a fair number of people in line said, well, in the DHCP world, blah, blah, blah. So I think there's still, I mean, given that it's not going to be a working group, or if it is, somebody better tell me about that. But I would say we could keep doing this on DRIU, and if the DHCP conversation starts overloading, then you can do it. But
I'm more concerned that there are really three communities here. I think DHCP and that layer of configuration, DNS, and now because of this HTTP.
Right.
And I don't want to piss off any one of those three constituencies by flooding their email boxes.
I don't mind doing that.
I think there's only two now because I think DHCP got shut down.
Okay.
Right.
Sorry.
And Mark, I just want to note, I mean, you've been with me a couple of times this week. This is the first BOF, but at two other side meetings. This has been the week at the IETF where the DNS people and the HTTP people finally came together and said, wow, you know stuff we don't. I don't like that. I'm learning stuff from you. This is really difficult. Mark, you have brought up a great difficult ending for the week. But I think this is
That's what really, I do.
Yeah. I think this is really good, and so I would like to keep as many of those communities on one list as possible. And it seems like the DRIU list so far has had them. And if some DHCP stuff pops up, great. But I agree with Tom that didn't have a very warm feeling toward it. And you can take it to DHCP. There's already a mailing list for that. So are you okay with that? Or
I'm fine with that as long as everybody, and we're not going to shut down the mailing list after the BOF.
I had no intention of it. And I don't even remember which area director I used to get the mailing. We're not going to shut the mailing list after the BOF? Nope. Warren says nope. So
okay, thank you.
Okay, so we still have bits of time. Here, let me go back to the slide for those of you who are wondering, what mailing list are we talking about? You took the clicker, I believe. No, you didn't. Okay, so there's mailing list information. We could do the line again. I would say, actually, do you want to do it? Okay, so great. Anyways, write that down, or write down at least the last bit. And I have hers already up, and no, I don't. just see if this is going to work. There's your clicker. And is it still asking? And there we go. Where's my DNS? You're on. And we have 15 minutes total with no questions. It's up to you if you want to talk for 15, talk for 10, how you want to do it.
I think I will zip through and just go through a handful of the slides. So this was a presentation I gave on Friday at the ICANN DNS Symposium. And what I tried to do here was actually look at this from a user perspective. So this isn't really necessarily a protocol talk. It's trying to talk about how the user experience will evolve if many of the things that we've been talking about come to pass. And a lot of this kind of recaps some of the talk we've had, so I'll try not to take too long. So we see a lot of switch to encrypted transports. We're seeing switches from a single system-wide resolver configured through DHCP to potentially per app extremely granular configuration. So what we're hearing is devices are going to switch from using one resolver per network to potentially dozens, possibly hundreds, actually, if we take some of the things we've heard about today to the extreme. So I will skip forward to all the good stuff about what all this can do for you. There are some slight trade-offs in terms of if you do a delta to what the DNS gives you today. We have a slight increased potential for user tracking. If we start doing some of this DOE work, it breaks some of the models enterprises rely on. Ooh,
I'm sorry.
you? Me.
It just, okay, stop touching Paul.
That are things like split horizon.
I give up.
Let me see if I can. Okay. Split horizon and interaction with VPNs. So we just need to worry about the complexity that adds. And of course, we know the resolver still sees all the traffic. So we've seen already that browsers are looking to do DOE in their own way. Let me skip on to... Right. So as we've heard today, what's happening in September, I think it is, Firefox has proposed turning DOE by default to Cloudflare. And we know that in the short term, the reality is that these contract-based relationships are all we have because we have absolutely no discovery mechanism. So it means there's going to be a precedent where there's a period of time where that is what is happening. And we're struggling here to figure out discovery mechanisms and ways to do this differently. And right now, I don't think any of us think that that is going to happen really quickly. So we have to think about this interim period where we're using potentially a single resolver for all the queries from a single app. So we've heard that the browser guys are going that way. And if you want to think about what that means for your end device, you have to think about where the browser fits into your whole experience of using DNS. How much of your queries go through the browser, how much goes through apps, and that could be different on a different device. So there's a whole set of questions around what the browsers do and the kind of models we've heard. The other thing that I want to raise is we're kind of forgetting all the rest of the apps here, because an end device isn't just a browser. There's a ton of stuff that's going on there. So what is going to happen in that space? Are they likely to maintain to just carry on using the system resolver, or are they going to follow the browsers and go down that same route? I think there are a few things that will affect that decision. One is that if native implementations of encrypted transports in system resolvers and system libraries is slow, and it has been to date. We saw it slow with DNSSEC. We see it slow at being at this. So with that being the case and privacy being a strong argument, more and more apps are going to consider following browsers and their model. We do see an increase in the quality and the range of libraries, so it's going to get easier for apps to make this choice. If you can just do something very simply in JavaScript, that's very attractive to a lot of developers. And it's probably quite a low threshold to thinking about doing this in the sense of the question of, are there enough servers to send this to? We have Cloudflare today. If we move to having 3, 4, 5, it becomes very tempting for those apps to just think, I'll just hard code this. I'll just go to Cloudflare 2. I don't have any overhead, and yet I tick the privacy requirement in terms of promoting my app and meeting those requirements. So again, this isn't a protocol issue, but there are big privacy gains here potentially, certainly to be had in the apps in certain contexts, but we really have to think about what is this going to mean for the overall user experience. So you could say, if all the apps are going to go down this road, you could ask 4 things of them so that the user still has visibility of what's going on. You could ask that they implement various transports, including transport options like DNSSEC, but that's now being muddied into some of the trust models, so that's an open question. We could argue that apps should, unless they have a good reason, they should respect the system resolver. And again, this comes back to the trust models. If we can develop good trust models to use, that's better. If we can't, is keeping the use of the system resolver better, because at least that's a central configuration point for the user. We'd like apps to be transparent about what they're doing with DNS. Right now in Firefox, I can see a very high-level result of the DNS query. I cannot see the wire format anymore. So for some people, that's a loss of transparency and visibility. So you're relying on each individual app to expose exactly what's going on. And I don't think we can assume that they all will. And of course, none of this can be enforced in the app. It's not part of the protocol. It's just the ecosystem and how the software will develop. So I think what's becoming a real thought now is that DNS is no longer part of the device infrastructure, and there is very rapidly going to be no single point of configuration for an end user. It's probably just going to become embedded in content delivery. There are very good reasons for this to happen, but it does change the nature of the concept of a name resolution system on an end device. So you've potentially got suddenly multiple configuration points, multiple transport and authentication options, multiple recursors. We'll see a shift in failure modes. Right now, for better or worse, we have the all or nothing model. Your DNS dies, you're stuck. This will become much more tied to the content endpoint. I'll be in a browser, these tabs work, these tabs don't, this app works, this one doesn't, what the hell's going on? How do I debug it? How do I even start? And you may have the reduced capabilities to debug in each of those contexts. Yeah, the days are gone where Wireshark and Dig are your friends, I think will be the truth. Will users notice or care? Probably not, because probably, I mean, it could literally be that happens, boom, your DNS queries from Firefox are all going to Cloudflare, for example. It could be, hey, we're doing something good for you. Don't worry your pretty little head about the details. Just carry on. Or it could be that they actually try and explain what the heck they're doing. And ironically, this could be really confusing to end users. It might scare them, and they might go, I don't know what's going on. Just click the most visible button I see. So that's interesting. I don't know if I've got time to...
I would say questions would be better. I think you had a section after TRR, or was that the last one?
That was it. Okay. Yeah, that was just...
TRR is an implementation thing for Firefox, so let's not do that.
Yep. Yeah. So, yeah, so it's... So yeah, in one, just very, very quickly, this is the current statement that I pulled from one of the Firefox blogs. And I think we've already explored the fact that this is just, we already have a really implicit consent model right now. Users just log onto a network and log on to the server. And what we're talking about in a sense is shifting the implicit consent to a given application from the network. So that's, I think that's fundamentally the core question that we're looking at in the trust model. And I will shut up and let...
We've got 5 minutes in case
Ted
either Ted is short or other people want to get up.
Thanks a lot.
Yeah.
So listening to this slide, what became very clear to me is that we really need to specify what the behavior is for resolvers that use DOE with respect to locally served domains, because otherwise they're just going to break.
Yep.
And that would be kind of a bummer because we're doing a lot of work that relies on them.
Yeah. So because I think I'm right in saying that Firefox has a fallback mechanism where if it just absolutely fails to resolve it, because obviously the external name server can't, it will fall back to using the local system resolver over UDP, which should then resolve you, but with some delay. Is that right? I'll let Patrick speak to that.
Yeah, there's soft fallback for all those things. .locals and some other things that are assumed to be local addresses. MDNS things aren't looked up in TRR at all. Anything that looks 1918-ish that comes back from the resolver, the result's thrown away and you do the fallback. There's a long set of things that are made to make this split horizon thing work. We also end up accidentally looking up net BIOS names and the things that aren't really in DNS because you can type them in the location bar. That all needs fallback to work. There's stuff to be done around here for sure.
Thanks.
Eric Niger and Akamai. I think two other risks I didn't see called out here, but I think are, besides the split horizon one, that are big important ones we should at least need to be aware of, is one of which is there are a lot of services out there, such as CDNs, that do DNS-based mapping, and where they send end users to is, like it or not, a result of where the DNS lookup is coming from. And today, the assumption a lot of those systems are designed with are users' DNS is either co-located with the user in their network, or that they're using a centralized resolver that sends EDNS clients, that sends EDNS zero client subnet. And if we go into a world where a lot of more and more users start using centralized resolvers that don't send ECS and are far from the users, that might help privacy for the DNS lookups, but is going to mean those users are going to be getting sent to places further away from them and more likely to be crossing national boundaries, and therefore may have more of a risk of their actual traffic and transactions and SNI headers going across places where there might be pervasive monitoring. So there are going to be some trade-offs here that are beyond just this. The other thing is that, like it or not, unfortunately, DNS is one of the few handles that ISPs feel they have to control, to implement mandates that come in legally from their governments. And I think that it's going to be important for us to think about what are going to be the side effects if we take that handle away at a large scale, and what are those ISPs going to start doing instead that might be a lot worse.
I think it's enterprises as well that are going to worry about that, lack of control of just bringing content onto their network.
Right, and I think like for enterprise, and it's probably worth separating those into two use cases. There's the cases where people control the endpoint. So the enterprise case, the home residential use case where you want to control what your kids are watching online, there's the schools. Those are things where we as the IETF can probably come up with some mechanism for how to kind of have a general way of allowing endpoints to control policy for domains. But then and then the one of middle boxes who aren't the endpoints is a separate one, and I think it's worth keeping track and explicitly thinking about the endpoint control over policy and the middle box flailing their arms in the air because they no longer have a way to enforce policy as separate.
Yep. So I think there are multiple actors with concerns with this change of model, and this was mainly looking at the end user, but you're right.
And Oliver's last because we've only got 3 minutes, so Oliver.
Okay, all over. Okay, Sarah. This is a very interesting presentation and thought-provoking, but I got a little bit annoyed, and probably not in a way you expected. You are assuming that the state that we were in, say last year, is something that is an agreed-on model. No, it is more like it is what we have ended up with through a small step of incremental steps that were taken because of convenience.
So I'm not arguing that what we have is the right thing.
No.
I'm arguing that there are pros and cons to the change, and we should be careful to understand and enumerate all of them.
Yes. And some of the things that you brought up there, like multi-connectivity, VPNs and other things, is stuff that we argued about forever in the MIF working group here for the IETF and finally had to give up on because nobody could figure out exactly what was going on because we had a wrong model in the beginning. So yes, it's good, it's different, but this also is a big opportunity. We can now actually give end users error codes that make a meaning to them that we don't have in the DNS protocol today because it sucks on error codes. Did I say that? Yes, I said that. Yeah, so we should think of this as we have to think of it both as a positive, negative, and where we're going as to the question of censorship, etc. That is, both goes in, are we taking the censorship away from the enterprise? Are we giving the censorship to now a central authority that is no control over? These are all open questions, and we end up with possibly having to be able to get more information from the resolvers about what they are doing, if they're allowed to say it. So we should be thinking about how do we go to make the world better, and not just what is going to work in the next 6 months. And the experiment that Firefox is doing with unnamed CDN is an experiment to see where we can go, what it leads to, and it's also encouraging others to come along and provide services.
And I think the only thing I'd say is what I'm worried about is that we will be tempted to solve that problem from a protocol and application developer perspective, because that's the people in the room doing the design and looking for performance gains and optimizations. And and we may not take all of the other concerns in when we do that.
Yes,
That's
it's
the
like
fear.
that the prior speaker was talking about a special optimization hack that certain unnamed companies use.
So we're out of time. Does anyone want to take a hum? Thank you. See you on the mailing list.
Oh.